Hello everyone and welcome to Bhanzu Classes. So I hope all of you are super duper excited for today's session, right? In the previous session we had started a very interesting chapter named as integers. Today we are going to continue with its two operations which we had talked about earlier, and we are going to talk about their properties. So what are we going to talk about today? We are going to talk about properties of addition and subtraction of integers, right? So before that, what did we learn in the previous session? We had talked about what are integers, what are addition of integers, what are subtraction of integers. How do we add and subtract the integers? By conceptual method and also on the number line, right? So now moving ahead to properties for addition and subtraction of integers in this particular session, right? So before we move ahead, I hope all of you are aware of the names of the properties, right? We have discussed them in your previous grade in the chapter whole numbers also. So what are the properties which we are going to learn about today? We are going to learn about closure property, commutative property, associative property. For integers, does they hold good? For addition and subtraction, we are going to check that out in this session today. And last but not the least, we'll also be talking about what is additive identity, right? Ready everybody? Yay! Let's start. So first of all, I'm going to talk about closure property. What does closure property states? Closure property states that if you add or subtract any two integers and we get an integer only, then we say it's true for that particular operation. So first of all, I'm going to check for addition. So for any two integers a and b, if you get an integer after adding them, if the sum is an integer, we say it's true. And yeah, you can see in the example, minus 4 plus 5. When solved, you get 1. 21 plus of minus 35 gives you minus 14. Yes, it's an integer. So this means integers are closed under addition. Integers are closed under addition. You can try out with any integer. You can also take one of the integers as 0 and check them out either with a positive integer or with a negative integer, because our answer will always be an integer, right? Now let's check out this property with the help of subtraction operation. Will it hold good? Let's check it out. For any two integers, a minus b is also an integer. Why? See, 4 minus of minus 5 is giving me plus 9, right? Minus 35 minus 10 gives me minus 45. So integers are closed under subtraction. So whatever examples you take, whatever integers you take, after subtracting them, you will be getting an integer only. So this holds that integers are true, are closed for addition and subtraction, both the operations, right? Do not forget to check them out with any integer after the session. Next, very interesting property is commutative property, right? What do we do in this? We interchange the position of the numbers. The first position is taken by the second number and the second position is taken by the first number. But even if the answer holds same, then we say that particular thing is true for commutative property, right? This is what we had learned earlier. So now we are going to check it for integers under addition operation. So 5 plus of minus 4 is 1. Minus 4 plus of 5 is 1, right? So addition is commutative for integers. So even if I change the position of the integers, we got the same answer, right? You can see plus 5 and minus 4, we got the same answer, which is plus 1. So the general rule states that a plus b will always be equal to b minus a. This means addition is commutative for integers. Addition is commutative for integers, right? Let's try out for subtraction now. So if we interchange the position of the integers, do you think we'll be getting the same answer in subtraction? Let's see. So here you can see that we have 5, we have interchanged the position, minus 4 we have interchanged the position, but the answer we got after subtraction is not the same. 9 and minus 9, even though the digits are same, the signs aren't same. So that means subtraction is not commutative for integers. So the general rule over here states a minus b is not equal to b minus a. Again, do not forget to try it out with any integer, right? So for any integers, commutative property holds good for addition but not for subtraction, right? Not for subtraction out there. Next, very interesting property. I hope everybody is clear with closure and commutative property till now for addition and subtraction operation. Clear? Noted down everything? Yes. So now moving ahead to associative property. Try to recall. Here will we talk about 2 integers? No, my dear. Here we'll be talking about 3 integers at a time. And we are going to group them out. And even after grouping and doing the operation, if we get the same answer, we will be saying that they hold good for associative property. So let's check under the operation of addition first, right? So here you can see we have minus 5, plus 4 and plus 3, the numbers which we have taken as to check for associative property, right? So first we have grouped 4 and 3 and second time we have grouped minus 5 and 4. Because always we can solve 2 integers at a time, right? So we are getting the same answer. So this means associative property is good for addition of integers, right? Addition is associative for integers and the general rule says a plus of b plus c in the bracket will be equal to a plus b in the bracket plus c. You can check out with any 3 integers out there, right? Because first of all we need to solve the 2 integers and whatever answer comes we need to solve it with the remaining one. And if you get the answer same, it's associative. Let's check for subtraction. Do you think it will hold good for subtraction? I don't think so. Let's check it out. So for subtraction, here I am taking the 3 integers as minus 3, 4, 2, right? So what did we do? First of all, we have made a pair of this and then we have made a pair of this. And if you subtract them after pairing, we are getting different answers. So the general rule for associative property under subtraction says that a minus of b minus c is not equal to a minus b minus c. That means subtraction is not associative. So I told you, I am thinking that it will not be good. Yeah, it's not good. It does not hold true. You can check out with any integers. Got it? Yeah. So now let's take up a practice question for associative property. So I have given you 3 integers over here as minus 9 plus 5 and minus 4. So associative property under addition, right? So we need to add them after grouping and if we get the correct answer, it will be hold true, right? And we saw for addition is associative for integers. So let's check it out. Minus 9 plus 5 plus of minus 4 should be equal to, in the bracket, minus 9 plus 5, right, and plus of minus 4. So let's solve it out. What do we get? Minus 9, in the bracket we would get 5 minus 4 is 1 is equals to minus 4 plus minus is minus, right. So what do we get over here? Minus 8. Here also minus 8. So that means it holds good. It shows us the statement that a plus of b plus c is equals to a plus b plus c, right? It holds good for us. So this is how we check with any integers. Do not forget to try it out with any integers you feel like. And do check it out with 0 as well, right? So this was about the first 3 properties under addition and subtraction for integers. Now let's talk about the last topic for the day, that is additive identity. But before we discuss this identity, can you recall what's an identity? What is your identity if somebody asks you? What's my identity, right? We all are unique. So identity over here states that if you add a number to 0, it will never change the value of that integer. That means the identity of the integer remains same. It doesn't get changed. Like minus 6 plus 0 is minus 6 only. It didn't convert it into plus 6. The identity of a negative integer remains negative if 0 is added to it. The identity of a positive integer remains same if 0 is added to it. Right? So hence 0 is an additive identity for integers. So a plus 0 is equals to 0 is equals to 0 plus a, right? We'll get the same answer over here. It's actually not 0, it would be a over here, right? It will always be equal to a, the integer, whether 0 is added to it or not. So now let's solve two questions for additive identity. So what do we get over here? Minus 53 should be added to what to get minus 53? Its identity should not change. What should we add? Yes, you are right, we should add 0 over here. And what will be the answer for 15 plus 0? If you add a positive integer to 0, what do you get? Yes, you get 15 out there. Got it? So this is how we get the correct answers for additive identity. Do practice few more questions. So now it's time to summarize what all we had learnt in the session today. We had talked about properties of addition and subtraction, and I have made a small table for you so that you can recall everything out there. So we talked about closure property, commutative property and associative property. Under addition, all of them were true. Right? What tells us that? Equals to sign. Because we were getting the answer same or an integer in closure property according to the definition of the properties. But in subtraction, it holds good only for closure property, not for commutative property, not for associative property. Right? So where A, B, C are integers, any integers, do not forget that. Right? And last but not the least, we talked about that additive identity is A plus 0, 0 added to any integer, or any integer added to 0 will always give you any integer only, right? So it should be a over here, that is the integer. Yeah, I hope all of you got it right. So till we meet next, do not forget to check out all the properties with any integers you wish, like your favorite integers out there. Keep exploring, keep practicing. Till we meet next, pack your curiosity. Bye-bye.